Hi everyone, thanks for joining me today. Since we're approaching the 4th of July, I thought it'd be perfect to celebrate by diving into something that lights up our skies every year, fireworks. Beyond the sparkle and color, there's a fascinating world of science and chemistry at play. So let's explore how fireworks are engineered to create that magical spectacle. Fireworks have a long, colorful history that began over 2,000 years ago in ancient China. It's believed that bamboo thrown into a fire would explode with a bang, eventually evolving into the early gunpowder-based firecrackers. By the Middle Ages, fireworks had reached Europe, where they were used for royal celebrations and public entertainment. Today, they are a global symbol of joy and unity. And I don't know if anybody's got plans to watch them over the 4th of July weekend, but I know I certainly do. So what's inside a firework? A firework is basically like a mini chemical laboratory all packed into a shell. So inside there's two main components. First of all, we've got fuel that gives it the energy to launch into the air and also explode. We have oxidizers that supply oxygen so that burning can happen even in the air, because remember that in order for things to burn, they need oxygen. And as you go higher up in the air, oxygen gets thinner, so we kind of need to supply some extra. Colorants, which are basically metal salts that give different colors. And we also have stabilizers and binders that kind of hold everything in place. So altogether, this combo allows for fireworks to soar up into the sky, detonate, and then dazzle. So colors in fireworks come from very specific metal salts that emit different wavelengths of light when heated. So in particular, you can see on this table of salts, a lot of times they are combined with chlorine, sometimes it's carbonate, sometimes it's nitrate, but it's that metal, so that first element that gives it its color. So strontium makes red, copper gives us blue, barium makes green, sodium gives us yellow, and then we have a mix of strontium and copper give us purple, which makes sense because red and blue make purple. So what's especially interesting is how temperature control can affect color intensity. So especially for blue, which is one of the hardest to get right. If it's too hot, it gets washed out. If it's too cold, it's probably not going to be cold because it's an explosion. But chemists kind of really have to strike the perfect balance to get a good sapphire hue. So if you see any blue fireworks at the 4th of July celebration, make sure you're impressed by the chemistry and the fine balance they got. So how does this all actually work in the sky? So it starts with a fuse that ignites what's called a lift charge, propelling the shell upward. Basically, this is kind of like a mini rocket launch, where this is the first explosion that propels the shell up into the sky. So then there's a time delay, so that the second explosion doesn't happen until the shell is well up in the air. And the second explosion, which is called the burst charge, goes off. So inside that explosion, there are these little stars. We call them stars. They're actually pellets that contain those metal salts that burn and create those beautiful shapes and colors. So everything is very carefully timed. So you have, once it's in the air, the burst charge goes off, it ignites everything else, and that's the explosion that you see. So bringing it all back to the chemistry of what's involved, mostly this is a combustion reaction, which is just at its core sense a fuel reacting with oxidizers and oxygen to produce heat, gas, and light. So you see combustion reactions happen all the time. Anytime you see fire, it's a combustion type of reaction. These are highly exothermic, which means they release a lot of energy, and that energy doesn't just power the explosion, it also excites the atoms in the metal salts. And that's what causes them to emit light. When an atom is excited, it emits light, and based on what kind of atom that is the wavelength of light that it's emitting. And that's why we get those different colors. So that's why you need a different element to get different colors, because they each have their own wavelength that they will emit. So thank you so much for watching. I hope you learned a little bit about fireworks. Please keep in mind, if you're planning on using fireworks over the holiday weekend, to be safe, be careful. Like I said, these are explosives. They are combustive, and they are very exothermic. They give off a lot of energy, so just be very careful if you are going to be using them. They're equal parts science and art. And they bring people together, well, whether it's for 4th of July or New Year's Eve or any holiday. It's amazing just to see how a series of chemical reactions can translate into something so beautiful. So I hope you have a great holiday weekend, and see you next time. Thanks.